Hello to all my viewers, this is Dr. Dhaval Maheta, and today I will explain how to plot the ROC curve in probabilistic neural network in KNIME. A probabilistic neural network is a type of artificial neural network that is used for classification and pattern recognition tasks. PNNs are based on the Bayes theorem of probability and they work by estimating the probability distribution of the input data. PNN consists of four layers: an input layer, a pattern layer, a summation layer, and the output layer. The input layer receives the data and the pattern layer converts it into the probability density function by calculating the distance between the input data and the prototypes in the pattern layer. The summation layer combines the PDFs, that is a probability density function, and calculates the posterior probabilities, which are then passed to the output layer for the classification. PNNs have several advantages over other types of neural networks, such as their ability to handle non-linearly separable data, their fast training time, and their ability to classify the data with high accuracy. However, they are not as widely used as other types of neural networks because they can be computationally expensive and they require large amount of memory to store the prototypes. Once we run the algorithm, it is necessary that we check its classification accuracy. We have already discussed in the previous video that if a person is having a COVID and the kit detects it correctly, it is a success for us. So 50 is a success for us. A person is a normal and the kit detects that the person is normal, so 140 is also success for us. So 50 plus 114, 164 is that algorithm is able to classify the cases correctly. Misclassification has happened in 6 cases here and 22 cases here. Now we will generate the AOC. AOC is a measure of the overall performance of the classifier which ranges from zero point 0.1 to 1. The higher the AOC, the better the classifier at distinguishing between the two classes. The accuracy of the test depends on how well the test separates the group being tested into those with and without the disease in the question. So if you get the AOC in the range of 0.9 to 1, it is excellent. 0.80 to 0.90, good. 0.70 to 0.80, fair. 0.60 to 0.70, poor. And 0.50 to 0.60, the model is failing. A receiving operating characteristics curve is a graphical representation of the performance of the binary classifier system such as logistic regression, as its discrimination threshold is varied. The ROC curve plots the true positive rate against the false positive rate at various threshold settings. So you can see here the dark blue color diagonal line is just a random guess, and the ideal line is overlapping the y-axis and x-axis, that is a straight y line and straight x-axis, that is an ideal curve. This we can never achieve, but we want to go nearer and nearer to the idealistic situation. Two models are there, blue one and the red one. Red one is having more area under the curve, and therefore it is considered that this model, this method one, is having more classification accuracy, or rather we can rely more on this model. So how we can plot ROC? Let's see in KNIME. So first of all, I'll activate the input output from here. I'll double click on it. I'll browse the dataset, which is in CSV format. Click OK. Right click on it and execute. Now I'll activate the column filter. So that I can only consider those cases which are, I can consider only those variables which are necessary for our model. Configure. I check all the variables on left hand side: age, resting blood pressure, cholesterol, maximum hours of exercise, and heart disease are considered. Right click on it and execute. Again right click and you can see the filter table. Now I will activate the color manager. Right click on it and configure. Red color is for a patient having the heart disease. Green color is for the person not having the heart disease. Right click on it and execute. Now let's activate the normalizer. As these variables are on different scales, it is necessary that we normalize it. Configure. So the normalization, which will be considered as mean max normalization. Click OK. Right click on it and execute. Now let's activate the partitioning. Let's partition the data. Right click on it, configure. 80% is used for the training data and 20% is for testing data. The stratification will be done on the basis of heart disease. Right click on it and execute. Now activate the PNN learner. Right click on it, configure. Make sure that the target column is heart disease. Right click on it and execute. Activate the PNN predictor. Now this PNN predictor will get its data set from here, the remaining 20% data from here, and it will get its learning from here. Right click on it and execute. Now right click on it and you can see the predicted data. So in my previous video, we had discussed the classification accuracy can be generated with the help of scorer. So you can activate the scorer from here. Right click on it, configure, activate the heart disease, click OK, right click on it and execute. Again, right click on it and you can see the confusion matrix. In my previous video, we have already interpreted this confusion matrix. The classification accuracy is 78%. Now we want to generate the ROC curve. So just write down ROC curve here. Disconnect it from here. Right click, configure, prediction heart disease. Yes, this is for the original data set, and here we will only consider prediction for the heart disease. Click on general plot options, create image at plot, click OK, right click on it and execute. Again, right click on it and see the image. 0.822. It's quite good. It is quite good. So the area under the curve is 0.822. So what will be our interpretation? Let's write it down here. 0.822. An AOC value of 0.822 in an ROC curve indicates that PNN has a good level of discriminative power in distinguishing between the positive and negative classes. An AOC of 0.822 suggests that the model has a very good ability, we'll remove this, model have very good ability to correctly classify positive instances as positive and negative instances as negative one. In other words, the model predictions are much better, right? So these are the wordings which are to be used, much better than the random chance, but there may be many misclassifications or overlap between the two classes. So this is the way you can write the interpretation. So this is the way you can run ROC curve in KNIME. For more videos on KNIME, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos on KNIME.